Hello everyone, this is Group 6 presenting you the open source software vulnerabilities. I'm Harshita and along with me are my teammates Sandesh and Sharmila. We are producing the vulnerabilities related to Linux and VLC media player in this presentation. Let's get started with Sandesh.
Thank you, Harshita, and hello everyone. My name is Sandesh, and I will be talking about the vulnerability which was found in major Linux distributions. The CVID of this vulnerability is CV 2021-4034. This vulnerability is also known as PwnKit. This vulnerability has been hiding in plain sight for like 12 plus years and affects all versions of PKXX since its first version in May 2009. It's a memory corruption vulnerability in Polkit's PKXX, a SUID root program that is installed by default on every major Linux distributions. This vulnerability was discovered by Qualys researchers. This easily exploitable vulnerability allows any unprivileged user to gain full root privileges on vulnerable host by exploiting this vulnerability in its default configuration. The CVSS score for this vulnerability is 7.8 and the severity is high. First, we will see what is Polkit PKXX for Linux before going into technical details of the vulnerability. Polkit, formerly known as PolicyKit, is a component for controlling system-wide privileges like Unix in Unix-like operating systems. It provides an organized way for non-privileged processes to communicate with privileged processes. It is also possible to use Polkit to execute commands with elevated privileges using the command pkexec followed by command intended to be executed with root permission. Next is technical details of this vulnerability. This is the code snippet from the pkexec.c that I found on GitHub. This part of the code has a vulnerability which attackers might exploit if not patched. The beginning of pkexec main function processes the command line arguments from the line 534 to 568 and searches for the program to be executed if its path is not absolute in the directories of path environment variable. Unfortunately, if the number of command line arguments argc is 0, which means if the argument list argv that we pass to execve is empty, then argv0 is null. This is argument list terminator. Therefore, at line 534, the integer n is permanently set to 1. At line 610, the pointer path is read out of bounds from argv1. At line 639, the pointer s is written out of bounds to argv1. But the question is, what exactly read from and return to this out of bound argv1? When we execve a new program, the kernel copies our argument, environment strings, and pointers, that is argv and envp, to the end of the new program stack, as you can see in the below screenshot. Because the argv and envp pointers are contiguous in memory, if argc is 0, then out of bound argv1 is actually envp 0, the pointer to our first environment variable value. At line 610, the path of the program to be executed is read out of bounds from argv1, that is envp0, and points to value. At line 632, this path value is passed to gfind program in path because value does not start with slash, which is mentioned at line 629. Then gfind program in path searches for an executable file named value in the directories of our path environment variable. If such an executable file is found, its full path is returned to pkexec main function at line 632. Finally, at 639, this full path is written out of bounds to argv1, thus overwriting our first environmental variable. In other words, If our path environment variable is path is equal to name, and if the directory name exists in the current working directory and contains an executable file named value, then a pointer to string name slash value is written out of bounds to envp0. Next is mitigation of this vulnerability. Given that this vulnerability has been undiscovered by security researchers until recently, there is a chance that attackers will now use this opportunity to perform malicious acts. Hence, to prevent this vulnerability from getting exploited, it is recommended to update your systems with the latest security patch that most of the major Linux distributions have released.
Thank you, Sandesh. The next vulnerability is on the VLC media player, bearing the CVE number 2018-11529. VLC Media Player version 2.2 on Windows was prone to a use after free vulnerability, which an attacker can leverage to execute any arbitrary code via crafted MKV files. If there is any failed exploit attempts, that would likely to cause VLC to crash. So this flaw exists due to an improper sanitization that's used by VLC Media Player against the MKV files. The severity of this vulnerability is high, bearing the CVSS score of 8. This was initially discovered in 2018, and as a workaround, the users were asked to refrain from opening files from untrusted third parties or accessing untrusted remote sites, or even disable the Windows VLC browser plugins until any patch or upgrade was available. Let's see how this vulnerability was prone to an attack. This vulnerability is prone to a use after free memory allocation. This is a memory corruption flaw that is triggered when a program references a memory that it has been freed. This can cause a program to crash or use unexpected values or even execute arbitrary code. A hacker can potentially leverage this vulnerability to execute shell code or even achieve remote execution capability. Dereferencing a null pointer may result in an unattempted read or write from memory that is not mapped, triggering a segmentation fault or memory access violation. This may manifest itself as a program crash, or it can even be transformed into a software exception that can be caught by program code. Since the source code here is written in C language, dereferencing a null pointer is undefined behavior. Many implementations cause such code to result in the program being halted with an access violation because the null pointer representation is chosen to be an address that is never allocated by the system for storing any objects. Since there are many modules involved in this source code, we have shown a snippet of these codes. This is the source code of the VLC Media Player version 2.2 from AVI and ASF files. This is picked up from one of the modules where the memory is pointing to the dangling pointer after it is being freed. Then it goes on checking for any other null values and tries to return its value. And this is being replaced with a function name in the subsequent um, modules, like in the audio media player and in the video modules. So this is being done in the next version so that it is like an upgrade to the 2.2 version. So with this vulnerability, the attacker can easily execute any command on their victim's machine, like he can shut it down or take a screenshot or edit confidential data, run a program, view through a webcam, or inject virus. or he can even open a backdoor to use in the later. So, in other words, a attacker can do anything on the victim's machine as if the attacker were the victim themselves. So, initially, to combat this vulnerability, users were advised to disable any VLC browser plugins. Later, they came up with a upgraded version, and this vulnerability was resolved after upgrading VLC Media Player to version 3 and above. Handing over to Sharmila now to take up another vulnerability. Thank you.
Hello everyone, this is Sharmila and I'll be talking about the vulnerability which was found in all the Linux kernel versions below 5.1.17. The CVE for this vulnerability is CVE 2019-13272. A flaw was found in the way that ptrace traceMe functionality was handled in the Linux kernel. The kernel's implementation of ptrace can grant all the permissions to an attacker who can then misuse the relationship between the tracer and the process being traced. This flaw could allow a local unprivileged user to increase their privileges on the system or cause a denial of service. The CVSS score of this vulnerability is 7.8 and the severity is high. The impact of this vulnerability is root privilege escalation. Next, we will be discussing about the technical details of this vulnerability. The vulnerability was found in the ptrace.c file in the kernel. This is the code snippet from ptrace.c of the vulnerable kernel version 4.9.309. Here, the ptrace link function mishandles the recording of the credentials of a process that wants to create a ptrace relationship, which allows local users to obtain root access by leveraging certain scenarios with a parent-child process relationship. Here, the parent drops privileges and calls a function that potentially allowing control by an attacker. Next, we will be discussing about the mitigation of this vulnerability. The temporary fix for this vulnerability before the patched version of kernel was released by configuring SE Linux to deny ptrace. SE Linux, that is Security Enhanced Linux, is a security architecture for Linux system that allows administrators to have more control over who can access the system. The SE Linux boolean setting deny ptrace will deny all the processes, even those that are running in the unconfined domains, from being able to use ptrace function on other processes. This vulnerability was patched in the kernel version 5.1.17. This is the code snippet from the ptrace.c file of the kernel version 5.1.17. In this, when ptrace called for ptrace traceMe function, the ptrace link function would obtain an RCU, that is read copy update reference, to the parent's objective credentials, then give that pointer to get credential function. However, the object lifetime rules for things like struct credit do not permit unconditionally turning an RCU reference into a stable reference. So the summary is like, as a part of this project, we explored different kinds of open source software vulnerabilities and we came to know that how small weakness in the source code of the software can lead to major vulnerability which attacker exploits to gain an unauthorized access of the system. To explore further, we tried to exploit all these vulnerabilities in the virtual environment with the help of exploits available on GitHub. These are the references we used for this presentation and thank you.